Hello, and welcome to our SUSECON session called Vishay adds a dash of salt to keep their environment spicy but under control. It is session number CAS 1051. In this session, Ryan Watts and myself will discuss what Susa Manager is and how it has helped Vishay gain control of their environment. But first, let me introduce ourselves. My name is Anthony Tortola, and I am a senior sales engineer with Susa. Joining me virtually is Ryan Watts. He is a senior architecture engineer for Vishay Technologies. This is the session's agenda. I will be doing the Susa Manager overview while Ryan will describe how he applied Susa Manager's toolset. He will also give some real-world examples from his environment, such as NTP, Snmp, and so on. So let's start with a brief overview of Susa Manager, what it is and what it can do. This session may be a review for some, but it will be an introduction for others. So with that, let's dive in. If you could imagine your IT landscape is like a theater. And like a theater, there's a lot of work that happens behind the scenes. This allows the actors on stage to perform the show and provide the audience with what they came for, entertainment. As far as the audience is concerned, these hidden agents are performing some kind of quote-unquote magic by hiding the complexity of the actions being performed on the stage. We at Susa help operation and development teams perform the same kind of magic in the background. We do this by providing them with a robust set of tools to manage, maintain, and monitor their infrastructure. These DevOps teams using Susa Manager can hide the complexity of their infrastructure, providing a seamless and repeatable process for the lines of business or end users to consume. From day one to day two operations, Susa Manager has you covered. So Susa Manager was designed to be a Linux-neutral lifecycle management toolset for developers and operations teams to have control of their environment, from the core to the edge to the cloud. It is a best-in-class management solution that gives these teams the ability to reduce their costs by optimizing operations, reduce complexity by gaining control over ever-increasing complex IT infrastructure, and ensure compliance by providing the ability to enforce internal security policies and audit for any exposures to CVEs. As part of reducing complexity, Susa Manager can manage a variety of Linux distributions, not just its own. As you can see here, the supported Linux distributions are SUSE Linux Enterprise 11, 12, and 15 on our supported architectures, also RHEL 6, 7, and 8, and RHEL derivatives such as Oracle Linux and CentOS. And we also support Ubuntu 16, 18, and 20 LTS versions, along with Debian 9 and 10. And in the very near future, Susa Manager 4.2 will also support Amazon Linux 2 and the new RHEL clones Rocky and Alma Linux. Susa Manager further reduces these costs and complexity by managing those previously mentioned distributions no matter where they are. They could be on the public cloud, they could be in the data center, or both. Susa Manager will treat them all the same. Susa Manager could also run from a variety of platforms. It could run from a public cloud or locally in your data center. Anywhere Linux could run, Susa Manager can manage it. By the way, Susa Manager could also be installed on different architectures such as x86, 64, Power, or Z. This offers operation teams much more flexibility by letting them choose where to place the Susa Manager workload as they deem best. Susa Manager functions the same no matter where it's installed. Here we see what we call lifecycle management wheel. As we can see here, there are many layers and components to this wheel, and we place Susa Manager at the center because it can manage all the layers and components. So let's get started with the inner ring and automation. Having lifecycle automation reduces costs and complexity by delivering a consistent, repeatable server deployments time and time again. Susa Manager provides this ability to create, provision, and maintain these Linux workloads across the different landscapes, from core to edge to cloud. With virtual machine management, Susa Manager gives operators a complete view and control of their virtual machine lifecycle, from deployment to patch to package and configuration management. Operators also can have control of their environments by having the ability to create, start, pause, stop, delete virtual machines, and update their hardware settings from the same interface. Having this complete visibility allows operators to place workloads where they need to be and when they need to be there. For cluster management, Susa Manager can maintain a Kubernetes cluster underlying OS by keeping that OS up to date with the latest security patches and updates. This will ease security compliance issues, allowing operations teams the ability to enforce corporate security policies. Also, Susa Manager can monitor Kubernetes clusters with Grafana and Prometheus, giving the operators insight to resource allocation and consumption, and create alerts on those allocations and consumptions in case they fall out of bounds. For asset management, Susa Manager can give the operators a view into their ever-changing IT assets. And Susa Manager also not only can count how many Linux devices you have, but also compare it to your inventory to your software entitlements. This will keep your costs down just in case you've oversubscribed your environment. As mentioned earlier, Susa Manager can provision Linux servers, whether deployed to bare metal, virtual machines, or on a hybrid cloud. Susa Manager introduced a new provisioning tool called Yomi, which is based on Salt. Susa Manager, again, will treat any provisioned server located at the core, edge, or cloud all the same. For image building, operation teams can create KVM images or containers images for deployment. This allows you to have a catalog of images to choose for deployment. By doing it inside of Susa Manager, you can keep those images up to date by patching the image before deployment and afterwards for redeployment or initial deployment. Susa Manager can be treated as a trusted container source. No good lifecycle management tool would be complete without a solid package management capabilities. Susa Manager provides this with a feature called Content Lifecycle Management. For example, operators can download the packages from each one of the supported Linux distributions you saw before, and then have Content Lifecycle Management create channels with only the packages you want to deliver to your devices at any given time. Moving the packages across multiple stages from dev to user acceptance testing to production can provide pitfalls if you're doing this in a manual fashion. By having Susa Manager's Content Lifecycle Management do it, we can automate the process and ensure that each package level is the same across the different landscapes. Having controls of what packages you want to deliver to the server is only part of it. Operators can control when they deliver them with Susa Manager patch controls. Those controls operate where you could schedule the time when you want to deliver those patches. It could be on demand, it could be a week from now, it could be an hour from now. Whenever your maintenance windows are defined, Susa Manager can be scheduled to deliver those patches and packages during that window. Also, when the operation is finished, an operator can set up what's called an action chain. And within that action chain, for example, I could say, after I'm finished installing my packages, I want to restart a service. Or even I could reboot a device after the patch job completes, offering this great flexibility and control to the operators, and thus reducing costs because now you have a repeatable process installed. Just having complete control of how a system's deployed and package level is not enough. With Susa Manager configuration management capabilities, an operator can utilize a set of standardized configuration files and states that can be built to the company's internal security standards. You'll get to see some of these configuration files examples later in the session. In the end, the newly deployed or updated server will be configured to that company's build security standard, and those policies can be enforced. This will contribute to lowering the costs and complexity for the overall environment. With workload orchestration, you can control when and where the previously mentioned containers get deployed. Since these containers are coming from a known trusted registry, and by using containers that have been audited and patched, this will further reduce your compliance issues. Having an automated build deployment and patch configuration process is just part of the lifecycle. To complete the lifecycle journey, operators can redeploy servers after either a hardware failure, a hardware retirement, or just want to return a server to a specific point in time. And they want to do it utilizing the same tools they used to start with. So let's recap. In keeping with your environment healthy by having a repeatable process of deployments, patches, and configurations, and using Prometheus and Grafana to monitor and alert on resource allocation and consumption, and by having the ability to perform CVE audits or OpenSCAP scans, Susa Manager gives the operations and dev teams the knowledge to which security vulnerabilities are affecting your environment for compliance, and then having the ability to patch the vulnerabilities to security of servers and pushing security team approved configuration files are all examples of how SUSE Manager reduces your cost, complexity, and helps you with your compliance of your environment. Having SUSE Manager operation development teams have a powerful tool set to perform that magic for their end users. Thank you. I hope this review has given you a better overall understanding of what SUSE Manager is and what it can do. Now I would like to hand over the virtual mic over to Ryan, and he will discuss how he's able to use these SUSE Manager tools to help keep Vishay's environment spiced but under control. Thank you, and over to you, Ryan.
Hi, thank you, Anthony. My name is Ryan Watts. I've been working for Vishay for the past 2 years, managing Vishay's SAP environment as well as their web environment using SUSE Manager. Vishay is an international manufacturer of electronic components. Whether you realize it or not, you're probably using some of Vishay's components in your home on a daily basis. Our first product was created by the company's founder back in 1962. The Vishay metal strip resistor was groundbreaking at the time because of its temperature resistance. In this image, you see the founder's original drawing of this resistor on a napkin with a ballpoint pen. It now is part of the National Museum of American History. I was inspired by this, so coincidentally, I also now take all of my notes on napkins, so they are dual purpose. Prior to Vishay, I worked for a department store chain managing POS environment using SUSE Manager for retail. I hope to step you through a little bit of how we've integrated this technology here at Vishay. Years ago, I tried to accomplish what we're doing now by automating changes using C shell and RSH in Unix, and then over time that became SSH with bash scripts, in Linux. But today, of course, we're using SUSE Manager and Salt to do most of this functionality with greater speed, flexibility, and control across multiple platforms. Salt states can be written on the command line or in SUSE Manager's configuration channel web interface, which gives you added benefit of simple version management as well. And I'll step you through some of this. If you're new to Salt, I recommend going through this tutorial. It really gets you going and gets you started on some of the fundamentals. For reference, it's also a good idea to bookmark the module libraries. You can find just about everything you're looking for in here, and what you can't find, you can probably script and execute from your Salt master on the minions. This is an example where Vishay developers needed MySQL community database installed in place of MariaDB. A state was built in Configuration Manager which would uninstall MariaDB and install the MySQL community RPMs in its place, and it also would configure the my.cnf as well as some kernel variables for the system to run consistent throughout the infrastructure. So we ran this across our infrastructure and found that some of the servers were running slow because of the demand on those servers. They actually had different configurations, but this wasn't a problem. We were able to easily reverse this due to the Salt module file manage has a backup capability, so we could roll back the old my.cnf file and we were back up and going at their full state. We also were able to, inside of SUSE Manager, go back to a previous version before we integrated the my.conf change. So if this was run again, it wouldn't change these servers. After seeing this, we looked at the myconf template that we created, and using simple Jinja statements, we were able to modify the configuration so it was correct for production servers, and it would only modify these specific variables on production servers, and the rest of them would have the default in there. Since then, we've actually used the content lifecycle to filter out MariaDB, and we've included the MySQL community libraries as part of the custom repository, which we roll out. So essentially, what's happening when we run the formula now, or the salt state, is it's just changing the my.conf. And of course, if there was a server that came in that had MariaDB, it would still remove it, but for the most part, is just changing the configuration. Taking it the next step further, like I said, by using Jinja, JSON, XML, and Python in your salt states and templates, like as we discussed in the prior example, the my.conf and the kernel configuration were different. So we used SUSE Manager groups to specify which configurations would be used for which servers, simply by defining them in a Jinja statement. SUSE Manager groups are actually saved to each salt minion's pillar data. It's pretty easy to target this data in the salt state by running the -i group IDs, and then you can actually, in SUSE Manager, roll your mouse over the different groups, and in the bottom left-hand corner as a link, it shows you the group IDs. It's just a quick little thing that you can use to find it. Building dynamic configurations is relatively easy to do and can span across multiple platforms. Grains or pillar data is assigned to each server, such as distributions, release versions, and hardware types. And of course, you can use your own custom pillar data for minions as needed. Creating formulas in SUSE Manager is easy once you're familiar with the structure. This is the basic structure. So you have /srv/formula_metadata, which includes the actual formula itself, where it's organized in the formulas page in SUSE Manager, and there's usually a sample of what the pillar data will look like that you would include in there. The second location is typically where you would keep all of your salt states, is in srv/salt. That includes the actual salt functionality, the scripts, templates, and code. If you're just getting into writing custom formulas for SUSE Manager, I would highly recommend watching a SUSECON from a few years ago, where Rain Curtis steps you through this process and demonstrates it as he goes. After setting up these formulas, we wanted to easily configure servers while provisioning them from the vCenter without having to go into each server and modify them individually. We also integrated some default values into the formulas, so when we ran the high state on them, it would automatically take these states without having any involvement from SUSE Manager. When a new server is onboarded, many of the formulas automatically applied the defaults after running a simple high state, so you don't have to manually apply them. The defaults can be, of course, overridden by the formulas within SUSE Manager, which will change the salts node pillar data with the specified variables that you want to have included. It's also handy to be able to reverse changes made by the formula by adding an uninstall or disable checkbox in the formula itself. So next, I just wanted to step you through some examples that we have integrated into SUSE Manager as far as formulas, and kind of explain a little bit to you about them. First, we have Nfs Formula, which basically configures NFS exports on a server. Behind the scenes, it also is making sure that NFS only allows version 4 and from designated IP addresses, and it also disables anonymous access. We recently put through a Susa software change request from Vishay that it's now integrated into the SLES 12 repositories. This change improves the logging of NFS4, and it also allows you to specify the length of time in which connections are rechecked and relogged. Working in conjunction with NFS, we used IP tables rule along with salt beacons reactors to automatically notify us if any NFS connections happen to our servers. These can either send an email like in this example, or it could also create a Slack notification, and we also use a Teams channel to be notified of these types of things. Here's another basic example for Snmp. If running without anything specified in here, it will actually just configure the Snmp to our corporate Snmp servers. Of course, this can be overridden by using or specifying the server on the screen, and then of course running the high state. And as I talked about before, you'll notice there's an enable Snmp. So if this is unchecked and the high state is run, it of course would remove the configuration and disable the Snmp service. In addition to our standard monitoring, our servers also use a bash script that runs on a cron tab to notify us of system problems. We can change some of the parameters using this formula. Here again, by default, it's going to install the cron tab with the default parameters. If we go in here, we can then select to change this or even uninstall so we do not get the notifications. Our SAP environment at Vishay is pretty unique. So we developed a custom formula to configure and tune our SAP servers. This works in conjunction with SAP Tune and the syskettle tuning and can override the standard entries. It also sets some specific parameters that are used for vCenter. In this example, if you're not already familiar, Centrify is a world-class authentication and keystroke monitoring architecture, which can be installed and configured from this formula, eliminating this long list of steps that you typically need to do to install and configure Centrify. It also adds the repository, or the repository is added into our default repository for the SAP servers in the content lifecycle. So it pulls down the RPMs for Centrify and will install them automatically on the correct architecture. For security purposes, we monitor some of the files changes and are notified if they change automatically and the files themselves are healed to the correct state. To give you an example, here is again an email that we received notifying us that one of the files in PAM has changed. So we could then go and see what happened, why it was changed, and report on that. And aside from that, that's all I have. I'd be happy to answer anyone's questions or give any feedback or go from there. My name's Ryan. I appreciate it. Have a good day.